Right now, new and current customers can get any phone for free at US Cellular, so you can connect with all your family members this holiday season. You could even call your aunt who always makes you talk to your cousin, who's a dog. Or, maybe just send her a festive text. Get the gift of connection at US Cellular. Get any phone free today. US Cellular, built for us. Terms apply. Visit uscellular.com for details.
We value human connection with fewer distractions. US Cellular, built for us. Visit your US Cellular authorized agent, Cellular Advantage, located at 918 South Locust Street in Glenwood.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
Choose from a great selection of digital coupons and use them up to 5 times in one transaction. Check our app for details. Baker's, fresh for everyone.
This is SpaceTime, Series 23, Episode 24, for broadcast on the 25th of March, 2020. Coming up on SpaceTime, discovery of a new type of pulsating star, SpaceX to begin flying astronauts to the space station in May, and the ExoMars mission delayed until 2022. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered an unusual type of star that appears to pulsate on just one side. The strange teardrop-shaped star, reported in the journal Nature Astronomy, is part of a binary system located 1,500 light-years away. The star, known as HD 74423, has about 1.7 times the mass of the Sun and is in a very close orbit with a red dwarf companion, taking less than 2 Earth days to complete each orbit. This short orbital period has caused the larger star to become distorted into its teardrop shape by the gravitational pull of its much smaller companion. Astronomers began studying the system after first noticing the star's unusual chemical composition. You see, stars like this are usually fairly rich in metals. Metals are what astronomers refer to as any elements other than hydrogen and helium. But HD 74423 is metal poor, making it a very rare type of hot star. Most stars, including the Sun, exhibit pulsations across their surface. These rhythmic oscillations occur in both young and old stars, and can have either long or short periods with a wide range of strengths and different causes. But the one thing they all have in common is that the pulsations are visible across the entire star's surface. They're not just restricted to one side. The unusual single-sided pulsations are thought to be caused by the gravitational pull of the star's red dwarf companion, distorting the oscillations. The clue that led to its discovery came from citizen scientists poring over public data from NASA's planet-hunting TESS space telescope. The TESS data allowed researchers to observe variations in brightness due to both the gravitational distortion of the star as well as pulsations. They found that the strength of the pulsations was dependent on the aspect angle under which the star was being observed, and the corresponding orientation of the star within the binary system. Now, what all this means is that the pulsation strength varies with the same period as that of the binary. So, as the two stars orbit each other, astronomers can see different parts of the pulsating star. Sometimes they'll see the side pointing towards the companion star, and at other times they'll see the opposite side of the star. This allowed them to confirm that the pulsations were found on only one side, with the tiny fluctuations in brightness always appearing in their observations when the same hemisphere of the star was pointed towards the telescope. One of the study's authors, Dr. Simon Murphy from the University of Sydney, says although astronomers had long theorised that such systems exist, this was actually the first time one had been observed. He says scientists expect to find many more similar systems as the technology to listen inside the beating hearts of these stars improves.
So this is a binary star, so it's two stars that orbit each other. So they're very close in space. They revolve around each other a bit like the moon goes around the Earth. They do this every 1.6 days. So as far as binary stars or double stars go. This is actually a really short period.
We've had hot Jupiters orbit single stars in that period of time.
Yeah.
For binaries, this is really quick. They must be close together, and I guess that explains the weird shape we're seeing in the primary?
Absolutely, yeah. So because they're so close together, you get this rather large tidal distortion. And the tidal distortion is greatest on the face of the star that faces the companion. There's not any mass being transferred between the stars. What it's really doing is it's drawing the plasma, if you like, of the star into a tidal bulge on the side of the star that faces the companion. Again, to use the Earth-Moon system as an analogy, it's a bit like how the moon raises ocean tides on Earth, except these objects are much more massive and much closer together, so the size of the tides is huge. We're talking probably 100,000 kilometers if I was just to estimate it off the top of my head.
They would be tidally locked, so they don't rotate, I take it?
Yes. They'll rotate in the same amount of time that it takes them to orbit each other.
Yeah.
So they'll always show the same face to each other. Again, like the way we always see the same side of the moon.
Tell me about these pulsations that we're seeing, because this is what the story's all about.
The hottest star, the biggest star, is pulsating. Most stars pulsate, by the way. The sun actually pulsates with a period of about 5 minutes. Just that the sun's pulsations are so small that you really need good telescopes to be able to see that. You can't see that with the naked eye.
Told it rings like a bell.
It does ring like a bell, that's right. Yeah, so most stars pulsate. This particular star pulsates with periods of around 1 hour, so much more slowly than the sun, but also with larger amplitude. And the interesting thing in this star is that the pulsations are confined to one hemisphere. So they're confined within the hemisphere that faces the companion. So they're essentially trapped on one side of the star, the same process that causes the tidal bulge. So the tides are trapping the pulsation on one side of the star.
What would cause that?
It's actually to do with the density and the temperature of the star. If we get technical about it, the pulsations only happen when the temperature of the star is just right. And in that region that's tidally distorted, the temperature of the star is a little bit cooler, and that enables the star to pulsate, but only in that side.
I take it the primary and the secondary star, they haven't crossed each other's Roche limits or anything like that yet?
That's right, yeah. They're not overflowing their Roche loads yet. I should also say, by the way, when you said what's causing that, the tidally trapped pulsation, I mean, this is something we're actively working to solve. Jim Fuller, who is one of the co-authors of the paper, he's based at Caltech. He's working on the theory and trying to, develop a sound physical and mathematical model of what's happening. So the answer that I just gave you is a small piece of that story, and the final part of the story is still on the way. We don't have a sound description yet of what's happening.
It's a piece of the puzzle.
Exactly, yeah. We've done the observing, we've described the phenomena, and Jim and some other theoreticians will come along and explain the phenomenon.
And this was all done thanks to data from TESS.
Yep, that's right. Yeah, TESS is this spacecraft that's looking for planets orbiting other stars, but we're using TESS to study the stars themselves. Now, TESS data are public as soon as they're available, so anyone can go and look at them. And some citizen scientists, they used to be called amateur astronomers, but there's nothing amateur about it. These guys really know what they're doing. They were just poring over TESS data, trying to find something interesting or new, something that jumped out at them. And they saw this system, and it didn't fit in any of their boxes. It wasn't like anything else that they'd observed. And so they sent it to the professional astronomers, which is how the first and second authors, Gerald Handler and Kurtz, that's how they got involved. And they sought to explain the same thing. Now, Don had predicted some 40 years ago this would happen in a binary system, and he just hadn't observed it yet. So it took the precision of the TESS data and the quantity of the TESS data that we're now getting to find a system like this.
Now, back in the old days of Kepler, you sort of knew where Kepler was looking because it was always staring at that one portion of the sky. With TESS, it's covering the whole sky. Roughly where was this? I know it was 1,500 light years away from Earth, but what direction of the sky would you be looking at?
Midway between Crux and Canopus.
Not far from the second brightest star in the sky, the Southern Cross. Cool.
Yes. I should also add its visual magnitude is 8.6, so it's not a naked eye object. You will need a decent telescope. That's 100 times fainter than what you can see with your naked eye, so you would need a telescope to see that.
That's Dr. Simon Murphy from the University of Sydney. And this is SpaceTime. I'm Stuart Gary. Still to come, SpaceX to begin flying astronauts to the space station in May. And later in the science report, a special feature wrapping up what we know so far about the COVID-19 Chinese coronavirus. All that and much more still to come on SpaceTime. NASA has confirmed that SpaceX will fly astronauts to the space station in May using its Falcon 9 rocket and Crew Dragon 2 capsule. The historic flight will be the first manned mission launched from American soil since the mothballing of the Space Shuttle fleet in 2011. It's the major milestone in NASA's commercial crew program to use private contractors to transport crew to and from the space station, thereby allowing NASA to focus on the Artemis deep space missions to the Moon and Mars using the Orion capsule and SLS rocket. NASA says the two-man Dragon test flight has been slated for mid to late May at the earliest. It was almost exactly a year ago, back in March 2019, that a Crew Dragon 2 capsule successfully undertook an unmanned test flight to the space station, returning to Earth and splashing down in the North Atlantic Ocean 6 days later. Meanwhile, the other company contracted to transport crew to the orbiting outpost, Boeing, is continuing with its joint investigation with NASA to determine what went wrong during its abortive Starliner CST-100 test flight last December. The Starliner mission was meant to duplicate the Dragon's successful unmanned test flight to the space station, but failed, placing the spacecraft in the wrong orbit. So far, investigators have found software errors affecting the mission elapsed timer, which incorrectly polled the time for the Atlas V launch vehicle 11 hours prior to the launch, thereby triggering an orbit insertion burn too early, placing the spacecraft into a low orbit without enough fuel to reach the space station. But the problems didn't end there. They were made worse by an intermittent space-to-ground forward communications link issue, which hampered mission managers' ability to command and control the spacecraft during the mission. And NASA also uncovered a third issue, another software coding error, this one affecting the spacecraft's service module jettison and disposal sequence. See, the program is meant to detach the service module from the crew capsule following the deorbit burn and before atmospheric re-entry, thereby exposing the crew capsule's crucial heat shield. The service module, which contains the spacecraft's support systems, is meant to maneuver away from the crew capsule during this operation. However, it appears the disposal sequence program was incorrectly passed on to the module's integrated propulsion controller, which would have caused the service module to be pushed towards the crew capsule rather than away from it. And that could have resulted in an impact, destabilizing and damaging the crew capsule and its heat shield, ultimately destroying the spacecraft. Luckily, the error was detected and patched before the deorbit burn. But when combined with the earlier problems with Starliner, such as the parachute failing to open during Starliner's ascent to orbit abort test, and the ongoing software issues with the company's Boeing 737 MAX aircraft, it's not painting a very rosy picture for the aerospace giant. This is SpaceTime. Still to come, a new satellite tracking station for Alice Springs, and the ExoMars mission to the Red Planet delayed until 2022. All that and much more still to come on SpaceTime. Arianespace is to develop a new satellite tracking station at a technology centre near the Australian outback town of Alice Springs. The Centre for Appropriate Technology, located 5 kilometres south of Alice Springs, is set to host the new satellite tracking system, which will comprise multiple instruments encased in a 3-metre-tall clamshell observatory dome. It'll be the latest in a growing list of commercial satellite ground infrastructure projects on the site. The others include the existing Geoscience Australia satellite ground station and the recently announced Viasat real-time Earth satellite tracking station, which will be a hybrid space and ground network for Earth observation and remote sensing operations. Of course, Alice Springs already hosts the Pine Gap Joint Defence Facility, 18 kilometres southwest of the town. This massive spy satellite ground station is jointly operated by the Australian and United States governments for the Australian Signals Directorate, the CIA, the NSA, and the National Reconnaissance Office. Officially known as the Australian Mission Ground Station, but also known by its code name Rainfall, Pine Gap is a key link in the Echelon network. Echelon is a signals intelligence surveillance and espionage program collecting and analysing data from a vast network of spy satellites. Also known as the Five Eyes, Echelon is a joint project operated by the United States in collaboration with Australia, Canada, the United Kingdom and New Zealand. The Echelon program was created back in the late 1960s during the height of the Cold War to monitor the military and diplomatic communications of the Soviet Union and its Eastern Bloc allies. The network has now evolved into a global system for the interception of intelligence and surveillance of military and terrorist operations. The Pine Gap base includes a massive computer complex with 38 radomes controlling and collecting data from US spy satellites as they pass over a third of the planet. And it just happens to be the third that contains the world's most strategically significant hotspots, including China, the Middle East, and large parts of Russia. Its Central Australian location was chosen because it's far too remote for spy ships passing in international waters to intercept any signals. Pine Gap works closely with the Australian Defence Satellite Communications Station near Geraldton and the Harold E. Holt Naval Communications Station at Exmouth, both in Western Australia. The Australian Defence Satellite Communications Station near Geraldton uses a complex of multiple satellite tracking dishes to intercept signals and communications from Russian, Chinese and other nations' spy satellites for the Australian Signals Directorate and the NSA. The complex also includes a separate joint US-Australian military communications ground station. Meanwhile, the Harold E. Holt Naval Communications Station further north at Exmouth operates the most powerful transmission station in the Southern Hemisphere, providing very low-frequency radio transmissions for United States and Australian naval vessels in the Western Pacific and Eastern Indian Ocean. This is SpaceTime. The European Space Agency and the Russian Federal Space Agency Roscosmos have decided to postpone the launch of the second ExoMars mission to study the red planet until 2022. The joint project team made the decision after evaluating all the work still needed to be done before an authorization to launch could be given, and concluded that the risks to launch this year were simply too great. Mission managers believe that far more testing is needed to ensure that all the spacecraft software and hardware components are fit for the mission ahead. The situation has been further exacerbated by the ongoing Chinese COVID-19 coronavirus pandemic. The primary goal of the ExoMars mission is to determine if there's ever been life on the red planet and to better understand the history of Martian water. ExoMars will be the first mission to search for signs of life at depths of up to 2 meters below the Martian surface, where biological signatures of life may be uniquely well preserved. The ExoMars rover named Rosalind Franklin includes a drill to access the Martian subsurface, as well as a life search laboratory which is kept in an ultra-clean compartment. Roscosmos Director General Dmitry Rogozin says both agencies want to ensure a successful mission and can't allow any margin of error. ESA Director General Jan Werner supported those views, adding that more verification tests were needed to ensure a safe trip and the best scientific results on Mars. All the flight hardware needed for the launch of ExoMars has now been integrated into the spacecraft. The Kazachok landing platform's been fitted out with its 13 scientific instruments, and the Rosalind Franklin rover with its 9 science instruments recently passed its final thermal and vacuum tests in France. The latest ExoMars parachute dynamic extraction tests have been completed successfully at NASA's Jet Propulsion Laboratory, and the main parachutes are now ready for the 2 final high-altitude drop tests in Oregon. Meanwhile, the descent module has been undergoing its propulsion system qualification trials over the past month. And the combined ExoMars descent module and landing platform have undergone environmental testing in Cannes in order to confirm the spacecraft is ready to endure the harsh conditions of space on its journey to Mars. The new schedule envisages a launch between August and October 2022, which will be the next time Earth and Mars are at their closest, taking into account the 7-month travel time. This is because Mars, being further out than the Earth, takes 687 Earth days, almost twice as long, to orbit the Sun, compared to Earth's 365.25 days. Further complicating matters are the fact that both planets have elliptical rather than circular orbits around the Sun, and both orbits are inclined at slightly different angles relative to each other. Apart from the 2022 mission, the ExoMars program also includes the Mars Trace Gas Orbiter, which was launched from the Baikonur Cosmodrome on a Proton rocket in March 2016, achieving Martian orbit insertion 7 months later. Trace Gas Orbiter is studying the Martian atmosphere in order to gain a better understanding of methane and other trace gas emissions which could be evidence of possible biological activity on the red planet. The Trace Gas Orbiter also delivered the Schiaparelli lander, which sadly crashed onto the Martian surface during its landing attempt. You're listening to Space Time. Still to come, a special feature wrapping up what we know so far about the COVID-19 Chinese coronavirus. All that and much more still to come on Space Time. A new study has confirmed that Jupiter's iconic Great Red Spot is continuing to shrink. The gas giant is the solar system's largest planet, with more mass than the rest of the solar system other than the Sun combined. Its spectacular beige, salmon and brown swirling cloud tops are shaped by jet streams, winds and vortices into numerous parallel bands and coloured cyclonic patches, one of which, the Great Red Spot, clearly stands out from the rest. This Earth-sized anticyclone has been a feature of the Jovian skies for over 350 years, pretty well ever since telescopes were first pointed at the heavens. But the Great Red Spot's been dramatically decreasing in size over recent years. Back in the late 1800s, the Great Red Spot was some 41,000 kilometres wide, big enough for Earth to fit inside it 3 times. But then in 1979, when NASA's twin Voyager missions flew past the gas giant, they measured the Great Red Spot at a dramatically smaller but still respectable 23,300 kilometres wide. And the vortex has continued to shrink ever since, with a Hubble Space Telescope image taken in 1995 measuring it at just 21,000 kilometres across. Another measurement taken in 2009 showed that it had shrunk to a diameter of just 18,000 kilometres. In 2012, amateur observations revealed a noticeable increase in the rate at which the spot's shrinking, by some 933 kilometres a year, and it was also changing its shape from an oval to a circle. The most recent measurements show its rate of shrinkage has slowed down, but it's still getting smaller, now down to under 16,500 kilometres across, and it's turned a decidedly orange colour rather than red. The cloud layer is extremely opaque, making it hard to observe what's actually happening deeper down. Now, using new laboratory experiments and computer simulations, scientists from the University of Central Marseille have been able to study the dynamics of large vortices, providing a better understanding of how they're formed and structured. They've concluded that despite its reduction in surface area, the thickness of the Great Red Spot has remained remarkably consistent over time. The findings, reported in the journal Nature Physics, will be compared to new observations being undertaken by NASA's Juno spacecraft during its next close flyby of the gas giant. You're listening to Space Time. Drama has surrounded SpaceX's latest launch of another 60 Starlink broadband internet satellites into orbit. The Starlink 5 mission was flown from Space Launch Complex 39A at the Kennedy Space Center at the Cape Canaveral Air Force Station in Florida. The launch had been delayed by 3 days after a first launch attempt was scrubbed when an engine issue triggered a last-second launch abort. Now that may well have been an omen of things to come, as when the Starlink mission did fly, one of the Falcon 9's Merlin 1D engines suffered a sudden shutdown during the ascent to orbit, although it didn't affect orbit insertion, one of the advantages of having 9 engines on the core stage. Still, it wasn't the only problem. Once it had deployed its satellite payload, the first stage rocket also failed in its attempt to land on the drone ship Of Course I Still Love You, which had been pre-positioned downrange in the North Atlantic Ocean.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
It's T plus 40 seconds, and we've just had liftoff of our Falcon 9 vehicle, taking our Starlink payload to its targeted deployment orbit. We are now throttling down and throttling back up in preparation for max Q, which is coming up here in about 10 seconds or so. Max Q is the maximum aerodynamic pressure that the vehicle sees throughout ascent, so this is the largest structural load that the vehicle will see.
Maximum aerodynamic pressure.
And there's that call out for max Q, confirmation that we've just passed through max Q. Coming up in about a minute, we will have 3 events in rapid succession, the first of which being main engine cutoff, or what we call MECO. This is where all 9 of our M1D engines shut off and slow the vehicle down for the following event, which is stage separation, and that's when the first stage separates from the second stage. And then finally, the lighting of our second stage MVAC engine, which we call SES-1, or second engine start 1. Now, if you've been following our Starlink missions, you know that we've reduced the number of burns on the second stage for these missions from 2 burns down to just 1 single burn. This allows the second stage to provide 70% of the velocity needed for this mission, which allows the first stage to use less fuel and thus making first stage recovery much easier. So today we will again only be doing one burn of that second stage engine.
MECO 1. Stage separation confirmed. And back ignition.
And there we've just had MECO and stage separation. That stage separation confirms the successful fifth use of our first stage booster. Second stage MVAC engine lighting up and taking that second stage to its targeted orbit. We're just a few seconds away from fairing deploy. Again, this fairing was used once before on our very first Starlink mission. So this means that we've successfully reused this fairing. So now let's see if Miss Tree and Miss Chief can catch those fairing halves today.
Stage 2 is on a nominal trajectory.
Acquisition of signal, Bermuda.
Our second stage, its Merlin vacuum engine is currently burning and will continue to do so for a few minutes. It's carrying 60 Starlink satellites for eventual payload deploy. But we're going to focus the next few minutes on our first stage. Currently right now, after stage separation, that first stage is boosting, still gliding up without any engine power. It's hitting apogee just about now, and for the next few seconds, it's going to start to freefall down to the Earth's surface for an attempted first stage recovery on our drone ship in the Atlantic Ocean. As our first stage reorients itself, we're going to prepare for the first of 2 engine burns on that first stage to aid our recovery, the first of which is coming up in about 90 seconds. It's known as our entry burn. We fire 3 of the 9 Merlin engines in the opposite direction the way we're heading. We do this in order to slow down the vehicle about 25% before we hit the dense part of the atmosphere. Not performing this burn would put unnecessary strain on our first stage. It only lasts about 10 seconds. And although our first stage only takes a few minutes to get from its apogee down to the Earth's surface, our 2 fairing halves takes much longer.
Stage 1
entry burn startup.
Stage 2 continues to follow a nominal trajectory.
Stage 1 entry burn shut down.
Our entry burn has just completed. The next step is our landing burn. It's about 90 seconds from now. In terms of velocity reduction, with the remaining velocity, the denser part of the atmosphere actually slows our Falcon 9 by 80%, and the landing burn achieves just that last bit of reduction down to 0. And although we're focused on first stage recovery at the moment, at T plus 9 minutes, a little bit less than that, our second stage, its engine will cut off, will then confirm it's in good orbit, and will then begin the preparations for payload deploy.
Starting terminal guidance. Stage 2 FTS is saved.
We're still waiting on call-out and confirmation for that first stage, but that's our secondary mission. Right now we'll focus on our primary mission with that second stage and our Starlink satellites. We're waiting for that confirmation of second engine cutoff.
We have MECO 1.
Our cutoff has completed. We're now waiting for confirmation of good orbit before we begin payload deploy.
Expected loss of signal.
So we've achieved that good orbit for our second stage, but we're not in the right
Newfoundland.
position in that orbit yet. Second stage is now going to coast in this orbit for a few minutes. During this time, you're going to see the second stage is going to start to spin along its central axis. This gives the Starlink satellites the momentum they need to space themselves out over time after they deploy. Think of it as if you were hanging on the edge of a merry-go-round and you jumped off and it slings you out. We use this natural deployment, and it prevents us from having to install complex and heavy separation mechanisms on each and every satellite.
The Falcon 9's first stage for this mission had previously flown on the Iridium 7 Next mission in July 2018, as well as the SEOCOM 1A mission in October 2018, the new Centaurus Saturn mission in February 2019, and the second Starlink mission in November 2019. And time now to take a brief look at some of the other stories making news in science this week with a science report. And today we have a special report wrapping up what we know so far about the COVID-19 Chinese coronavirus. The World Health Organization is reporting that the pandemic has now claimed over 10,000 lives in more than 166 countries, with around 250,000 confirmed cases now reported. Each day we're learning a little bit more about this deadly disease. The virus's mortality rate remains at 3.4%. That compares to under 0.1% for a normal seasonal flu. Older people, those showing signs of sepsis, having blood clot issues, or with compromised immune systems are far more likely to die than the general population. And COVID-19 is also far more infectious. Studies suggest that a person with a normal seasonal flu would infect an average of maybe 1.3 people, but a person with COVID-19 could infect double that number, and you don't have to show any symptoms to be infectious. Epidemiologists believe that between 20 and 60% of the world's adult population could end up catching the virus. Studies by the New England Journal of Medicine and the journal Nature indicate that COVID-19's incubation period is around 5 days, but it could take up to 14 days, which compares to just 2 to 4 days for a regular flu. Also, there's a 19% hospitalization rate for those suffering from COVID-19, compared to just 2% for the flu. Studies also suggest that COVID-19 can survive on surfaces for up to 2 to 3 days, and it's not yet known if surviving COVID-19 gives you any form of immune protection. So, how does COVID-19 compare to other pandemics? Well, the severe acute respiratory syndrome SARS outbreak of 2002 and 2003 was spread from Gansu province in China to 26 other countries, taking 8 months to be contained, with a fatality rate of almost 10%. The bird flu influenza has been around since at least 1918, when it was called the Spanish flu pandemic, even though it actually originated in Kansas. It killed an estimated 50 million people and infected 500 million worldwide. Of course, bird flu's had a resurgence over the past decade or so, with strains like H1N1, swine flu, H5N1, and H7N4. In recent years, it's infected more than 1,600 people, killing almost 700 globally. That's a fatality rate of close to 60%. Then there's the Middle East respiratory syndrome MERS, which actually began in Jordan, although everyone says it was Saudi Arabia. It was transmitted from infected camels, claiming 858 lives from 2,494 confirmed cases, resulting in an initial fatality rate estimated to be 34.4%. But as additional data came in, the death rate was revised down to just 0.1%, which is actually in line with other known human influenza viruses. Of course, thanks to COVID-19, the world as we know it has dramatically changed. In fact, in some places, the thin veneer of civilization is starting to break down, with panicked hoarders raiding stores and supermarkets for supplies, resulting unbelievably in fistfights over toilet paper. And then there are the rows of empty shelves, more reminiscent of socialist Venezuela and the fall of communism in the Soviet Union than a modern Western society. Normally packed city streets are looking almost deserted, more like an early Sunday morning than a late Saturday night. Restaurants and bars are closed or near empty, theatres are shut, and many nations are now in lockdown with international borders closed. The Netherlands has cancelled the Eurovision Song Contest. Germany is describing it all as the most trying period in its history since World War II. And France has ordered the closure of major tourist attractions, including the Eiffel Tower, the Louvre, Moulin Rouge, and the French Open. Meanwhile, Spain has followed Italy in placing its entire country into lockdown, ordering people to stay home. Officially, Italy has now surpassed China as having the highest death toll from the virus, although the Chinese figures can't really be relied upon. In some countries, people are being ordered to self-isolate at home. In others, they're being asked to work from home. Australia has formally closed its borders with the rest of the world. Gatherings of 500 or more people are now banned in open areas, meaning concerts, exhibitions, festivals, and most sporting events, including the Australian Grand Prix, have been cancelled, and the few sports still on are playing to empty stadiums. Meanwhile, gatherings of more than 100 people indoors are now also banned. That's affected weddings, religious services, and community gatherings. Even more amazing, court proceedings involving juries have now been postponed, as has random breath testing by police. Those most at risk, our senior citizens, are being isolated from the general public for their own protection. Anzac Day commemorations, which mark the sacrifice of veterans and those still serving, have now also been cancelled. Even Sydney's famous Royal Easter Show and the Vivid Lights Festival have been called off. The federal government says that the growing list of restrictions could be in place for at least 6 months. The world certainly is a different place today. Meanwhile, United States Secretary of State Mike Pompeo has called in the Chinese ambassador to formally reprimand Beijing over its initial cover-up of the coronavirus. It's been revealed that when Beijing first realized the seriousness of the virus and its potential impact, they immediately removed their military from the area to protect them from the outbreak, but allowed the general population of Wuhan to remain, resulting in their exposure to the disease, which then quickly spread through the local population and from there to the rest of the world. Beijing then compounded their cover-up by detaining and arresting local doctors, including 33-year-old Dr. Li Wenyang, who attempted to warn the world about the threat being posed by the coronavirus. Incredibly, Beijing then charged him with spreading false information, forcing him to write a confession. He then conveniently died of the disease weeks later. Journalists have tried to expose the extent of the virus's spread in Wuhan, its deliberate cover-up by Beijing, or report on the horrific live meat markets from where the virus originated, have simply disappeared. These so-called wet markets sell live exotic animals for food, ranging from bats, snakes and dogs to highly endangered pangolins, civet cats and even Australian koalas. In early February, China Global Television Network released a video featuring a young Chinese man wearing a surgical mask soliciting hugs from Italian residents to encourage them in the fight against coronavirus. The ramifications of that are now being felt across Europe. The growing criticism of the Communist Party's cover-up has sparked China's official Xinhua news agency to warn that Beijing was considering imposing pharmaceutical export sanctions, which would plunge its critics into, and I quote, the mighty sea of coronavirus. Beijing's foreign ministry has also begun to falsely claim that the virus was actually spread by US soldiers. It's also revoked the press credentials of American journalists working in China. Of course, rumours and innuendos go both ways, and it's been widely reported that the COVID-19 virus was genetically engineered. But that's a claim that's been dismissed in studies reported in the journal Nature, which show that it's far more likely to be the product of natural evolution rather than any form of genetic engineering. The genetic engineering claim grew because the Wuhan outbreak occurred near the Chinese military's Wuhan National Biosafety Laboratory, located at the Wuhan Institute of Virology. This is the only biohazard lab in China designed to meet biosafety level 4, the world's highest, and is equipped to research high-level pathogens such as SARS, smallpox, Ebola, and hemorrhagic fever. Adding further to the mix are numerous reports of underpaid People's Liberation Army scientists regularly selling lab animals to local street vendors in order to supplement their meagre incomes. The world really has become a different place. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free twice-weekly podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
With Kroger brand products from Bakers, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Bakers, fresh for everyone.